we are going to learn about preparation methods and properties of ozone. Okay, first of all, the chemical formula of ozone is O3. This is a chemical formula of ozone. Ozone is one of the allotrope of oxygen. So, oxygen allotropes are dioxygen, like it is denoted as O2, and trioxygen, it is denoted as O3. These are oxygen allotropes. Okay. Next one. Today I am going to discuss preparation methods of ozone. Ozone molecule is exist three forms in nature. First one is this molecule is exist gaseous state in nature, and second one, this molecule is exist liquid state in nature. Finally, this molecule is exist solid state in nature. Okay, so this ozone molecule generally exists three forms in nature. First form is gaseous state, second form is liquid state, and the third form is solid state. Most probably, ozone molecule is available stratosphere in atmosphere. Atmosphere containing three zones. First zone is troposphere, second zone is stratosphere, and the third zone is mesosphere. Especially this ozone molecule available stratosphere in atmosphere. Okay, that is a occurrence of ozone. But this ozone layer is used in so many purposes. Most probably, ozone layer is used to filter the high frequency light radiation. Means high frequency ultraviolet radiations are absorbed. That is the main importance of ozone layer. Okay, ozone layer is available stratosphere in atmosphere, but this layer absorbed high frequency ultraviolet radiation. That is the importance of ozone layer. Naturally, this is available stratosphere in atmosphere. This is used to absorb the high frequency light radiations like ultraviolet radiation. Okay, and next one, this molecule is exist three forms in nature. First form is a gaseous form, second form is a liquid form, and third one is solid form. But the gaseous form of ozone exhibits pale blue color. The gaseous form of ozone exhibits pale blue color, and liquid form of glucose is exhibits dark blue color. And finally, The solid form of ozone is exhibits violet color. Okay. Generally, the ozone molecule exists three forms in nature. First, gaseous form. This gaseous form ozone is exhibits pale blue color. And next one, this ozone molecule exists liquid state in nature. These molecules, liquid state ozone molecules, are exhibits dark blue color. And next one, ozone molecule exists solid state in nature. The solid state ozone molecule exhibits violet color. This is the different colors of ozone molecules. And next one, preparation method for ozone molecule. Ozone molecule, most probably ozone is a natural available source. It is available from nature. Like these molecules are available stratosphere, in atmosphere, but generally in laboratory purpose, ozone molecule is used in laboratory purpose. That ozone is prepared by using artificial method. That method is known as electric arc method. Electric arc method. Electric arc method. This method is known as artificial method or synthesis method. Synthesis process or man-made process. This ozone molecule is prepared by using man-made process. Man-made process. Okay. This is known as artificial method. Another name is artificial method. Okay. First, I am going to discuss artificial method for the formation of ozone. First one, oxygen gaseous molecules are taken in one container. Oxygen gaseous molecules are taken. These gaseous molecules are taken in one container. These molecules react with electric arc. These molecules react with electric arc. Generally, the oxygen molecules are react with electric arc. These molecules are completely, means these oxygen molecules, the total reacted oxygen molecules are converted to ozone molecules. For example, 100 moles of oxygen molecules are to take one beaker. Only 10% oxygen molecules are converted to ozone molecules. O3 molecules. Means in generally this container containing totally 100 molecules. To assume this container totally containing 100 molecules of oxygen, dioxygen. So 100 molecules of dioxygen is present in it. This container react with electric arc. Only the 10% dioxygen gaseous molecules are converted to ozone. Means the 10% dioxygen molecules are converted to ozone. Okay. Only the 10% dioxygen molecules are converted to ozone. For example, this container containing totally 100 dioxygen molecules. These container react with electric arc. Only 10 molecules are converted to ozone. Okay. Means the 10% dioxygen molecules are converted to ozone molecules. This is a important point in this preparation method. Okay. Only 10% dioxygen molecules are converted to ozone molecules. And next one, in this reaction, for example, 3 moles of dioxygen gaseous molecules are converted to 2 moles of ozone. In this reaction, these products are gained such amount of heat. For example, in this reaction, the products are gained 285 kilojoules of heat. In this reaction, the products are gained 285 kilojoules heat. In any reaction, products are gained such amount of heat. The type of reactions are known as endothermic reaction. This reaction is known as endothermic reaction. This reaction is known as endothermic reaction. Okay. Generally, simple reaction, 3 moles of dioxygen is converted to 2 moles of ozone in the presence of electric arc. This reaction is taken. This reaction, products are gained such amount of heat. That heat is delta H is equal to 285 kilojoules. Okay, in this reaction, products are gained 285 kilojoules heat. That point is based on this reaction is known as endothermic reaction. That reaction is known as endothermic reaction. Okay, this is the preparation method for artificial preparation method for ozone. Okay, and the next one, some properties of ozone molecule. Some properties of ozone molecule. Properties of ozone. Properties of ozone. Okay. Generally, ozone is molecular oxygen. This is a molecular oxygen or trioxygen or molecular oxygen. Ozone molecule exhibits diamagnetic in nature. Diamagnetic in nature. But the dioxygen exhibits paramagnetic in nature, but trioxygen like ozone molecule exhibits diamagnetic in nature. Why? What is the reason? This molecular oxygen contains some paired electrons are present in it. Paired electrons are present in it. That is the reason. Okay. The trioxygen molecule or ozone exhibits diamagnetic in nature. Why? What is the reason? The diamagnetic nature is exhibited in this molecule due to this is the molecular oxygen. This molecule containing paired electrons. Any molecule containing paired electrons, that molecule exhibits diamagnetic nature. Unpaired electrons are present in it, that molecule exhibits paramagnetic nature. Paired electrons are present in it, that molecule exhibits diamagnetic in nature. Okay. And next one, ozone molecule structure is observed. This is the angular structure. Okay. So generally oxygen containing 6 valency electrons. So the 6 valency electrons, this is a Lewis dots. So these are the Lewis structure of ozone molecule. So this is the first resonance structure, and this is second resonance structures. These two structures of resonance structures of ozone molecule. Okay, and next one, the structure is angular structure. And next one, applications of ozone molecule. What are the importance of ozone molecule in our regular life? For example, potassium permanganate, KMnO4. This reagent is used in laboratory purpose. Okay, this reagent is used to make so many chemicals. So this reagent is plays very important role in different chemical industries. But ozone molecule is used to make potassium permanganate. Ozone molecule is used to make potassium permanganate. And next one, ozone molecule is act as best oxidizing agent. Ozone molecule is act as best oxidizing agent. Ozone molecule is act as best oxidizing agent. Lead sulfide react with ozone molecule. It is converted to lead sulfate. For example, okay, PBS. So, or PBS, lead sulfide react with oxygen to produce lead sulfate. Okay, PBS react with 4 moles of oxygen to produce lead sulfate, and another oxygen gaseous molecules are eliminated. This is a non-stoichiometric reaction. This reaction is not balanced. This is a non-stoichiometric reaction. Lead sulfides react with molecular oxygen like ozone to produce lead sulfate. The sulfide is converted to sulfate. This reaction is based on the ozone molecule is act as best oxidizing agent. And simple uses, ozone molecule is used to sterilize water molecules. To sterilize by water. Ozone molecule is used sterilization of water. So this is one of the important use. This molecule is used sterilization of water. And next one, ozone molecule is used, pure silver is converted to silver oxide. That process is known as tarnishing silver. Ozone molecule is involves for the process of tailing of mercury. Okay, and ozone molecule is used for the formation of rust of iron. That process also involves ozone molecule. Okay, this is some of the important applications of ozone molecule. Once again, repeated in these points like introduction, preparation methods, and uses of ozone. First one, ozone is one of the allotrope of oxygen. This ozone molecule available 3 states in nature. First state is gaseous state, and the second state is liquid state, and the third state is solid state. The gaseous state ozone molecule exhibits pale blue color. The liquid state ozone molecule exhibits dark blue color. The solid state ozone molecule exhibits violet color. Okay, this is the introduction for ozone molecule. And next one, artificial preparation method for ozone molecule. Artificial preparation method, best method is electric arc method. Best method, electric arc method. For example, this method is clearly observed. First, to take dioxin gaseous molecules. These dioxin gaseous molecules are take one container. These dioxin gaseous molecules react with electric arc. These dioxin gaseous molecules are converted to ozone molecules. Okay. So, in this reaction is clearly observed, only the reactants 10% dioxin gaseous molecules are converted to ozone molecule. This is a special drawback in this method. Only in reactants 10% dioxin molecules are converted to ozone molecules. Okay, this is a special drawback in this method. And next one, in this reaction is observed, the products are gained such amount of heat. For example, 3 moles of dioxygen react with electric arc. These are converted to 2 moles of ozone molecules. In these ozone molecules, gained such amount of heat like 285 kilojoule heat is gained. In any reaction, products are gained such amount of heat. That reaction is known as endothermic reaction. These points are based on this reaction is known as endothermic reaction. Formation of ozone is best example for endothermic reaction. Okay, and next I am going to discuss some physical properties and uses of ozone. In generally, ozone exists 3 forms in nature. So, and another point is observed, ozone is molecular oxygen. Ozone is a molecular oxygen. This molecule electronic configuration is observed, or some paired electrons are present in it. That point is based on this is exhibits diamagnetic in nature. This molecule exhibits diamagnetic in nature. And next one, this is structure. Ozone molecule structure is angular structure. This is exhibits 2 types of resonance forms. This is the first resonance form. This is second resonance form. And next one, uses of ozone molecule. Generally, ozone molecules are used best oxidizing agents. For example, lead sulfide react with ozone. The lead sulfide is converted to lead sulfate. The addition of oxygen atoms, that process is known as oxidation process. These points are based on ozone molecule is act as best oxidizing agent. And next one, ozone molecules are used for the sterilization of water. That is a simple application. Okay, first one, this is act as oxidizing agent and this is used for sterilization of water. Okay. And next one, ozone molecules involves in different processes. For example, tarnishing silvers, and the next one, tailing of mercury and rust of iron. These processes are involved. And next one of the important uses, generally KMnO4 is used to make so many compounds. This is the best reagent in laboratory. So this is the best reagent in different types of chemical industries. But this reagent is used this reagent is prepared by using ozone molecule. So these are the introduction, preparation method, and physical properties uses of ozone molecule. Okay, this is the explanation for introduction of ozone, preparation methods of ozone, and physical properties of ozone, and finally applications of ozone molecule. Okay, this is the explanation of ozone. Next one, chemical properties of ozone molecule. Okay, next one, chemical properties. Chemical properties of trioxygen or ozone. Chemical properties of ozone molecule. Generally, ozone molecule is act as best oxidizing agent. So this molecule react with alkene group of compounds. First of all, what is the meaning of alkene group of compounds? Which type of compounds are known as alkenes? Carbon-carbon bonded with double bonds. The type of hydrocarbons are known as alkenes. Okay, carbon-carbon bind with double bonded functional group. The type of hydrocarbons are known as alkenes. This alkene group of compounds are taken. For example, ethene, alkene. This is the alkene group of compound like ethene. This molecule react with ozone to produce ozonides, means CH2, CH2. The trioxygen bind with in this molecule. So this type of molecules are known as ozonides. That molecule is known as ozonide. Okay. So in generally, the ozone molecule react with alkenes to produce ozonides. This ozonide react with reducing agent in the presence of water. This ozonide react with reducing agent in the presence of water. This ozonide is converted to aldehydes. This ozonide is converted to aldehyde molecule. In this reaction, symmetrical alkenes are taken to produce only aldehydes, and unsymmetrical alkenes are taken to produce aldehydes and ketones. That is a simple difference in this method. Okay, in this reaction, this is symmetrical alkene, double bond functional group, both sides having same molecules. The type of alkenes are known as symmetrical alkenes. Symmetrical alkenes react with ozone molecule to produce ozonides, and these ozonides react with the reducing agent in the presence of water to produce aldehydes. In this reaction, the starting molecule is taken as unsymmetrical alkene. The starting molecule is taken as unsymmetrical alkene. This unsymmetrical alkene react with ozone to produce same molecules like ozonides, and then react with reducing agent in the presence of water. That unsymmetrical ozonides are converted aldehydes and ketones. Okay. So next one, ozone molecule react with alkynes, carbon bind with a triple bond functional group. The type of hydrocarbons are known as alkynes. The general formula of alkynes is CnH2n-2. Best example for alkyne is acetylene, CH triple bond CH. Alkynes, this molecule is known as acetylene. Acetylene, like alkyne group of molecules, react with ozone molecule to produce same molecules like ozonides. Okay, this is ozonide. This is ozonide. Okay, that ozonide molecule react with reducing agent like zinc in the presence of water. This ozonide molecule react with zinc. Zinc is act as a best reducing agent. Zinc in the presence of water to produce similar molecules like aldehyde group of compounds. Okay, right? So this is the alkenes and alkynes group of compounds react with the ozone molecule. Okay, this is one of the important chemical property. And next one, another properties are observed. First one, ozone molecule react with pure silver. Okay, ozone molecule react with pure silver. For example, pure silver react with ozone molecule. Pure silver react with ozone molecule. It is converted to silver oxide. And eliminated few amount of dioxygen gaseous molecule. This is one of the important preparation measure for dioxygen. Okay, so ozone react with pure silver. So the pure silver is converted to silver oxide. This process is known as tarnishing of silver. Tarnishing of silver means the formation of silver oxide from silver by the involvement of ozone. That process is known as tarnishing of silver. Okay, the formation of silver oxide from pure silver by the involvement of ozone molecule. The process is known as tarnishing of silver. And next, another chemical property is observed. Pure mercury is taken. This mercury react with the ozone molecule. This pure mercury is converted to mercurous oxide and eliminated few amount of oxygen gaseous molecule. This process is known as tiling of mercury. Tiling of mercury means for the involvement of ozone to loses the meniscus layer of mercury. That process is known as tiling of mercury. This is a best example for the tiling of mercury. Finally, the ozone molecule involves tarnishing of silver and tiling of mercury. Okay, so another important chemical property is fifth one. Ozone molecule react with potassium iodide in the presence of moisture. This is the potassium iodide. Potassium iodide react with ozone molecule in the presence of water, means moisture, in the presence of moisture. Okay, potassium iodide react with ozone. Potassium iodide react with ozone to produce potassium hydroxide, and iodine gaseous molecules are eliminated. Iodine gaseous molecules are eliminated and a few amount of oxygen gas is liberated. Finally, this reaction is used to liberate the iodine gaseous molecule. Potassium iodide react with ozone in the presence of moisture like water. It is converted to iodine gas. The potassium iodide is converted to iodine gas. This iodine gas exhibits violet color. Violet color fumes are liberated. So, violet color fumes are indicated by free iodine gaseous molecules. Once again repeated, in this reaction, potassium iodide react with ozone molecule in the presence of moisture. The total potassium iodide is converted to free iodine molecules. The free iodine molecules are exhibits violet color. The free iodine molecules are exhibits violet color. That iodine molecules react with hypo solution. Hypo, Na2S2O3. This is the chemical formula of hypo. Hypo is used to make for the cleaning purposes of films. Hypo solution is used cleaning purposes of films, different types of films, color films. Okay, hypo solution react with iodine gas. Hypo solution react with iodine gas. Okay, hypo solution react with iodine gas. So it is converted to Na2S4O6. It is converted to Na2S4O6 and sodium iodide molecules are eliminated. Sodium iodide molecules are eliminated. In this reaction is observed 1 mole of iodine react with 2 moles of hypo solution. 1 mole of iodine react with 2 moles of hypo solution. Means the above reaction is also observed. 1 mole of ozone involves in this reaction to produce 1 mole of iodine gas. Means the number of equivalents of iodine is equal to equivalents of ozone. Iodine is used to estimate the quantitative analysis for hypo solution. Okay, so the number of equivalents of iodine is equal to the number of equivalents of ozone. So these are the 3 internal links in these two reactions. First one, so these 2 reactions are used to calculate the quantitative analysis of hypo for the given reaction. In these 2 reactions are observed the number of moles of ozone is equal to the number of moles of iodine. Okay, so the number of iodine molecules are used to calculate the number of moles of hypo. Finally, the number of moles of O3 is equal to the number of moles of I2. Okay, so the ozone molecule is used to calculate the quantitative relationship between hypo and ozone, between hypo and iodine. Finally, the ozone molecule is involves for the estimation of quantitative analysis. That is the importance in this reaction. This reaction is based, the ozone molecule is used quantitative analysis in different chemical reactions. That is the importance of ozone. Once again repeated, in these reactions, ozone molecule react with alkenes to produce ozonides. These ozonides react with strong reducing agent like zinc in the presence of water. It is converted to aldehydes. And ozone molecule react with alkyne group of compounds in the presence of zinc and water. These are also produced different types of aldehydes. And ozone molecule react with the pure silver to produce silver oxide. This process is known as tarnishing of silver. Ozone molecule react with mercury to produce mercurous oxide. This process is known as tailing of mercury. And next one, ozone molecule react with potassium iodide to produce iodine gaseous molecules. The number of equivalents of I2 is equal to number of equivalents of O3. And then second reaction is observed, the iodine molecule react with hypo to produce sodium iodide. These iodine molecules are used to estimate the quantitative analysis, quantity of hypo solution. Finally, the ozone molecule is used to calculate the quantitative analysis. Ozone molecule involves quantitative analysis in different chemical reaction. So these two reactions are based on, finally ozone molecule is used to estimate the quantitative analysis in different chemical reaction. This is the explanation for chemical properties of ozone molecule.